Section 5.6b is about perpendicular lines. Just like I did with parallel, we'll show you what perpendicular means and then use it to solve some problems. Here, this first equation, it's in slope-intercepts form, so we can see that the slope is negative 2/3 and that the y-intercept is 4, also known as the point 0, 4. So to graph this, we start at the point 0, 4. And we use our rise and run, negative 2 over 3. So I'm going to go down 2, to the right 3, down 2, to the right 3. Now it so happens that this negative could also be applied to the negative 3. So you could go up to the left 3, and that would also work. Either way is acceptable. So here we've graphed our first line. Now we'll do the same thing with the second one. You can see that the slope here is 3 over 2. And that the y-intercept is negative 1, also known as the ordered pair 0, negative 1. So we start right there. And then slope is rise over run, so we're going to go up 3, to the right 2, up 3, to the right 2. You also could go down 3 to the left 2, because negative 3 and negative 2 will give you a 3/2 also. And I'll graph the line here, and so now you notice that those two lines come together to form a right angle. If you took a piece of paper and laid it right in there, you would see that this forms a right angle. That means these two lines are perpendicular. They cross at a right angle. Now what causes that? Well, just like parallel, it's the slopes. Here the slope is negative 2/3 and here the slope is 3/2. But those aren't the same. For lines to be perpendicular, their slopes have to be opposite reciprocals. Opposite means the signs are different, and reciprocal means the fraction is flipped. If you have that, the slopes that are opposite reciprocals, they form perpendicular lines. Here's basically what that says in a key concept. Two non-vertical lines that are perpendicular if the product of their slopes is negative 1. Now, that's another way of saying opposite reciprocals, because let's do that. Negative 2/3 and 3/2. Let's take our two slopes and multiply them, because that's what the word product means, right? So multiply the reciprocals, or multiply the two slopes. 2 times 3 is 6. 3 times 2 is 6 with a negative. Well, what's that equal? That equals negative 1. So these two slopes form perpendicular lines. Now it also says just what I said before. The slopes are opposite and reciprocals. If that's the case, you know that the two lines that you have are perpendicular. Here we use the information of perpendicular lines to solve this. We want to find the slope-intercept form of a line that's perpendicular to this line and passes through this point. Well, first of all, we can see the slope of this line is negative 1/4. Now, I want a slope that's perpendicular to that. So I'm not going to pick the same slope. I'm going to pick a slope that is the opposite reciprocal. Well, the opposite will be positive, and the reciprocal of 1/4 is 4. So that's my slope that I want. And because my slope is perpendicular to this slope, that's the one I'm going to pick. The rest of it is similar to the way we've done this before. I'm going to plug in my x, y, and m here. So negative 2 for the y, m is a 4, x is a negative 3. 4 times negative 3 is negative 12, so I'm going to add 12. And this gives me a 10, so b is 10. So now I have a slope of 4 and a y-intercept of 10. I'll plug those in. Y equals 4x plus 10. Now let's check it here. Since my equation is supposed to be perpendicular to this equation, that means the slopes are opposite reciprocals. Well, negative 1/4 and positive 4 are opposite and reciprocals, so my two lines are perpendicular. Here's one more example that involves perpendicular lines. There is a small difference, though, and if you look at this equation, it's not in slope-intercept form. So it's not easy for me to pick out the slope. So what you want to do is isolate the y first and get it in slope-intercept form. We'll do that by subtracting 7x. Now you could write this as 3 minus 7x, but I'm going to do negative 7x plus 3 because I want to put it in slope-intercept form. Now we'll divide everything by negative 2. So y equals 7/2 x minus 3/2. So this is the equation that I can use because I can easily pick out my slope now. I can see the m of this equation is 7/2. Now I want an equation that's perpendicular, so I'm not going to use 7 over 2. I'm going to use 2 over 7 negative because I want the opposite reciprocal. So there's my m. I'm now going to find my b. I'm going to plug in my 4, my negative 1, and my slope. So negative 1 is my y, negative 2 over 7 is my m, my x is 4. So this is negative 8 over 7. So now I'm going to add 8/7 to both sides. So what you have here is you have a negative 1 plus 8/7. I'm going to rewrite negative 1 as negative 7 over 7 because that way it gives me common denominators. Negative 7 plus 8 is negative 1/7. So now I can say that my b is negative 1/7. So I have an m of negative 2/7. I have a b of negative 1/7. I'll plug those in. Y equals negative 2/7, x minus 1/7. So let's see. Here's my equation. It's got a slope of negative 2 over 7, and that is perpendicular to the slope of 7 over 2, positive, because they're opposite reciprocals. So this is a line that's perpendicular to the given line.